Hello and welcome to my channel. So today I'm going to uh, demonstrate the alternator regulator sine wave or waveform. So to do that, I have Honda Jazz 2007. Nothing is wrong with the alternator, but I'm going to demonstrate that to you today. So as you can see, I have back proved the 2-wire connector which is at the connected at the back of alternator, so here, and the 2-wire are here. So the yellow wire, this one, which is connected to the bottom side, but I don't know the pin number on the connector. So this one is ground wire and this one is signal wire to the from the PCM, and this might be connected to the PCM as well, but I haven't got the wiring diagram, so to show you that might be connected. So with the ignition off, so right now I have got ignition off. So let me do that like so in another. So I'm going to show you with the ignition off. So with the ignition off, the scope lead connected to this one. So there are 2 wires. So I've connected to this one, the scope positive lead, and we have got 0.5 or half a volt. And now I'm going to move the scope positive lead to this one, and I'm going to show you that what we have got on this wire while the ignition is off. So I have swapped or moved the scope positive lead to this one, to the other wire of the alternator regulator, and as you can see we have 0 volts. So I'm going to move this positive lead back to the previous one, which gave us half of volt, this one, and as you can see we have got 0.5 volt and the ignition is still off. So ignition is still off. We have 0.5 volt, and as you can see we have here 0.5 volt. That can be seen very, very clearly. That's the reason I have connected the scope screen to the monitor here. So now I'm going to turn the ignition on. So ignition is on now. Let me turn this off. So ignition is on now, right now, and we have 8.4 volts, and because the digital multimeter only can show the average voltage, because right now this voltage is switching from approximately 0 to 12 or 0 to source voltage, whatever right now the voltage is, because the engine is off. Now the voltage may be around 12 volts or lower than 12 volts. So the voltage is switching between approximately 0 to source voltage. So and digital digital multimeter only can show the average voltage. So now I'm going to switch the scope meter to lap scope. So I'm going to switch that to lap scope. So you will be able to see better here. So I'm going to switch that to lap scope. So as you can see, the voltage is switching from approximately 0 to because the engine is not running, so the voltage is, the high voltage is just below 12. So I'm going to freeze that, and I'm going to show you that the lower voltage and the higher voltage, or peak to peak in another word. So I'm going to freeze that. So I'm going to freeze that, and I'm going to use the cursor. So as you can see here, cursor 1, this one, is on the top peak or on the higher side of the voltage, and it shows 11.12, and cursor 2 is approximately here. As you can see, cursor 2 is 0.65, which is this one. So this is the voltage which is switching, but as you can see, we have still got the average voltage on the digital multimeter, 8.41. So now I'm going to exit this screen, and I'm going to go back to live data. So live. Okay, now we are on live. So the voltage is still switching. So now I'm going to start the engine. Okay, I have started the engine. As you can see now, the voltage is above 12 volt because the engine is running. And we still have this voltage fluctuation, so from approximately 0 to 12 volts. Now this is called the pulse weight modulation. So the frequency might be the same for this, but the duration of the on time is changing. So I'm going to prove that to you. I'm going to bring cursor here, but it's not going to be accurate, but I'm going to switch the scope meter to digital to pulse width, and also I'm going to switch back to a lap scope mode, and you will see that the cursor is almost showing the exact pulse width which the digital multimeter is showing on the pulse width mode. So I'm going to use cursor here. So sorry, when I'm looking down with the scanner to set, and I'm losing the top camera lens focused on the top monitor. So I'm going to press Y. So now I'm going to adjust the cursor. So let me switch to cursor 1. So and now to 2. Okay, let me freeze that to show you, because approximately when with the live image capturing by the scope, it's not going to be accurate that much. As you can see, 2.99 millisecond the pulse width. So I'm going to freeze that. So I'm going to freeze that. So I have frozen. Now I'm going to use the cursor. So better if I first adjust here the cursor. So 2 is aligned. Okay, as you can see, the cursor is aligned properly, and here, as you can see, it's 3.25 millisecond the pulse width. So I'm not changing the scope meter setting, so I'm going to go back to live capturing event. So and then now I'm going to switch to pulse width modulation. So I'm going to switch that to so I'm going to go to pulse width. As you can see, it's exactly the same, because the cursor line was not that much precise aligned with the pulse width line. So it's because we had 3.2 and the exact pulse width is here 3.5, something like that. So this is the part of the, let me go back to the scope mode. So I'm going back to the scope mode. So back to the scope mode. Okay, now this is one cycle. So starting, just leave it, just start from here, and then coming back and going back here. So 1, 2. So the on time of the one cycle is called pulse width. We don't care about the off time of the one cycle. We just need to know the on time of the one cycle, which is here, the two teeth, 1, 2, this is one cycle. For example, if you start from here, go up here, and then come back down, then go back here, this is 2. So start from here, this is 1, and this is 2. So this is the pulse width. We don't care about the off time of the signal, signal. We just need to know the pulse width. Now, as you can see, I'm going to bring the cursor on live capturing image. Okay, I have just almost aligned cursor on the part of the on time of the signal. So this is one signal. As you can see, this is the on time and this is the off time. So I'm going to show you the on and off time. So if we compare the relation of the on time to the off time, then we will go to duty cycle. So the duty cycle will compare the on time of the signal, of the one cycle signal, to the off part of the signal, which is this one. This is now off time of the signal, and this is on time of the signal. How do we know that? Because as you can see, the signal is grounding, and this is the period or the duration or pulse width, this. So the signal is on from here to here, so it's switching. So this is the pulse width, and this is the on time from the off, from one signal. So compare it to the off, compare it to the off part of the signal, so the part which is off. So I'm going to show you that in the digital multimeter here. So I'm going to exit once again from here. So I'm going to go and now I'm going to show you that so as you can see, from 100% or from one cycle, so 45, 44.8 or 45% is on and 55% is off. So I'm going to switch back the scope to the lap scope mode. So come on. So I have lost cursor. Now I'm going to bring cursor back. So cursors are back, and here. So this was the on time from the on time of the one cycle. So it's called duty cycle. So this is the on time come. So this is 55% off, and this is 45% on, and the duration in time is 3.33 approximately, because as you can see, the signal is moving little bit right and left. So this is that. Now I'm going to put, so as you can see now, let me see here. Okay, as you can see now, so that, let me zoom that in a little bit. Okay, as you can see, now I'm going to turn the headlights on. Where is the, so I'm going to turn the headlights on. Okay, as you can see, the on time or pole's width has increased. As you can see, the now one side of the on time is beyond the cursor one. So, as you can see, now I'm going to turn the heater blower motor on. As you can see, the on time is increased more. Now I'm going to put the rear windscreen defroster on. As you can see, even more. Now I'm going to turn the front windscreen wiper on. So as you can see, even more. So now, so if you see, let me zoom that in a little bit. So as you can see now, so when there was no much load, electrical load on alternator, so this was here. So the on time was 3.3 milliseconds something. Now I'm going to adjust the cursor. This is the cursor or still on the previous mode here when there was no any load on the alternator. So now I'm going to bring the cursor to a current mode, which is alternator. The on time of the pulse or the on time of signal is right now, and I'm going to see that with you. So I'm going to switch to 1, and now I'm going to bring that this way. It's going to be approx, but I'm going to show you exactly that how much. So this is approx. As you can see now, the pulse weight has increased from 3.3 to something 6.40 millisecond. And as you can see, everything is running. So the headlights, the rear windscreen defroster is on, the headlights are on, the wiper is on. So now I'm going to show you that exactly how much the, as you can see, the duty cycle also changed. As you can see, the off time has decreased and the on time is increased. So now I'm going to show you on digital on exactly how much is the duty cycle. Okay, I'm going to go first. As you can see, duty cycle or to duty cycle. So duty cycle has increased now from 45 to 82%. So now from one proper cycle, the 82% of the one cycle waveform is on. Sorry, I don't know what did I say. So from one proper cycle of the waveform, now 82% is on and 18% is off. So this is the duty cycle. Now I'm going to go for the pulse weight. So as you can see, it's approximately close where to where close to where our cursors were. So it's the pulse weight has gone from 3.3 to 6.8 when there is extra load on the alternator. So that is that. Now I'm going to show you the frequency. So this is the frequency. So the frequency is 122. So I'm going to rev the engine with the frequency and see whether the frequency is changing or these are preset or pre-programmed frequency in the control module. So as you can see, okay, I'm going to so the engine is at, so we have got right now 122.7 hertz. So I'm going to increase that. So as you can see, but frequency is not changing. As you can see now, I'm going to decrease load on alternator and see what the frequencies are doing. So first I'm going to turn the wipers off. So I'm going to turn the wipers off, so no frequency is changing. So next I'm going to turn the headlights off. No frequency is changing at all. So now I'm going to turn the rear windscreen defroster off. No frequency changing. And now I'm going to turn the heater blower off. So as you can see, now everything is off. This is off. This is off. Headlights off. Wipers off. But we still have 122.7 hertz. So now I'm going to switch that back to pulse width. So as you can see now, the pulse width from 6 point something has returned back to 3. And now I'm going to show you the duty cycle. So as you can see, the duty cycle has back returned to 45. So it means that it's preset, the frequency is not changing, but the duty cycle and pulse weight modulation is decreasing and increasing. So when there is more load on the alternator, more consumption of the electricity, so more the longer the pulse weight, the duration of the on time, and the percentage of the duty cycle. So more on in percentage of duty cycle and more on time, but the frequency is not changing. So when there is less load on the alternator or less electricity is used within the vehicle, so less pulse weight modulation or less duration of the on time of one cycle, and less percentage of the on time of the one cycle. So that was a demonstration of the alternator regulator. So if you have a problem with this, so for example battery is overcharging, we might have that the duty cycle and pulse width modulation stays all the time high, or if we have because when the ignition was off, we saw that there was half of volt on the one wire, or anyway, so one wire. So that's going to be for the diagnostic purpose, onboard diagnostic purpose, whether the ECU will see that whether the circuit is closed, short, or open. That is that. And so that was today's videos. So thanks for watching.